Judges, please help me to welcome the team from Monash University.
In these 4 seconds, 100 kilos of textiles were dumped in landfills in Australia. Over a year, this amounts to over 800 million kilos of textiles in Australian landfills alone. Of all the textiles we throw away, only 7% is captured and recycled, making it by far the worst waste stream in terms of recovery rate. Not plastic waste, not food waste, but textile waste. This has a devastating impact on both our marine and land environments, contributing to over 20% of global water pollution and 10% of global carbon emissions. This is why we at Enactus Monash set out to solve the Australian textile waste crisis. My name is Raghav. I'm joined by Emma, Amna, and Jessie, and we're here to present our startup, Circle.
Our mission started with an obsession to learn as much about the problem as possible. We wanted to make sure that we were targeting the core issue and not just treating a symptom. So we started at the epicenter of textile recovery efforts in Australia, charity shops. We conducted over 80 interviews from volunteers to the CEO of Salvos, basically anyone that would pick up the phone and help us learn. But we soon uncovered a shocking truth. Only 15% of the textiles that charity shops received can be used again. The remaining 85% are at the end of their lives and destined for landfill. We began to understand that something deeper was going on, and so after speaking to repair shops, upcyclers, councils, and textile manufacturers, we identified our first key insight. In Australia, all end-of-life textiles are destined for landfill.
We wanted to dig deeper to figure out what was going wrong. Why can't our textile recovery efforts do anything about an end-of-life textile? We soon discovered a common flaw. All of our textile recovery efforts are focused on making a textile last as long as possible as a fabric. This overlooks a crucial problem. Fabrics degrade over time. Eventually, they reach a point where they can no longer be used as a fabric. Well, whether you take an old rag and make it into... This was our second key insight. Current solutions only make textiles last longer as fabric.
So how do we overcome this? Whilst textile waste at the end of its life is no longer usable as a fabric, it's incredibly valuable when viewed as a resource. Think of the clothes in your wardrobe. Cotton, wool, silk, polyester. These are incredible raw materials when used as the inputs for new products. This was our third and final key insight, that Australian textile waste is a resource goldmine. We knew our solution had to view textiles not as a fabric, but as a resource. We had to design a solution that didn't merely extend the life of textiles, but gave them an entirely new life.
So with all these insights in mind, we needed a solution that was able to break down a textile into its fundamental materials in order to rebuild it again into something new. And this, we realized, is only possible with some sort of chemical process. So we partnered with the Biopriya Institute, a chemical engineering center at Monash, to help us interrogate several chemical recycling technologies. This scientific journey began for us in 2022, where we tried to turn textiles into activated carbon fiber. However, as we progressed in our research, we realized that at scale, the unit economics of this process simply did not add up, and there were other technical barriers to achieving this solution. This meant we couldn't build a truly revolutionary business with this as our core technology. So, after many sleepless nights, pivots, and failed experiments, we've finally built a revolutionary technology. We're proud to present C-Plast. C-Plast is a groundbreaking innovation that turns cotton and cotton polyester blended textiles into bioplastic.
Our technology can be broken down into 3 main processes: dissolving, regenerating, and bioplastic production. We start with our textile and combine it with an environmentally friendly and reusable type of liquid called an ionic liquid. When this powerful dissolving agent interacts with a fabric, it breaks apart the fibres, leaving it fully dissolved and prepared for the second stage of our process. With mixed blend fabrics, this process selectively dissolves the cotton, leaving the undissolved polyester as a solid, which can then be recovered and recycled.
In the second part of our process, we then manipulate this dissolved mixture and subject it to various conditions, which allows us to regenerate it and give it a complete new structure. What once was a fabric has now taken a form that can be used to create our product.
Finally, our regenerated material is further produced to produce a bioplastic product. With a slight tweak in production methods, we can create a bioplastic which has significantly different properties. For example, using a heat pressing method produces an extremely rigid and sturdy material, whereas using simple UV light exposure produces a bendable plastic.
So now that you understand our process, let's discuss what makes Circle and our product C-Plus so incredibly groundbreaking. Firstly, our process has been developed such that we can continuously reuse our input ionic liquid to exponentially decrease our input cost. Using a simple liquid capturing process, we can separate the ionic liquid from the rest of the process without losing any of its potency. In the lab, we've demonstrated a 93% recovery rate. But what does this mean? Well, if we follow the money, a typical ionic liquid process can cost up to $2,500 per kilogram. With our process, after 10 iterations, we can bring this cost to below $300 per kilogram, and after 50 reuses, we can bring this cost to around $60 per kilogram. That's a 98% reduction in our input cost. This is what's making C-Plus so revolutionary.
Our second game changer is our ability to recycle mixed blend fabrics. This process allows us to capture and recycle approximately 75% of all textiles thrown away in a single year, enabling us to truly tackle the textile waste crisis in Australia.
Our third final innovation is our product. Cellulose bioplastics are a category of plastic alternatives that have sparked global interest for two key reasons. The first reason is their nearly identical mechanical properties when compared to traditional plastic, and the second key reason is their particular excellence in high-stress environments, such as extreme temperature. So, if this material has such good properties, why don't we see it being used everywhere? Well, bioplastics are held back because of one key commercial obstacle: high production cost. This is because the traditional organic inputs used for these bioplastics suffer from extensive material sourcing and arduous chemical separation techniques. However, we at Circle have innovated to leapfrog this commercial hurdle through the use and recovery of our ionic liquid. To illustrate this, conventional bioplastic costs around $3.76 to produce 1 kilogram. But with our initial cost modelling, we project that at scale, C-Plus will produce bioplastic at a cost of $2.95 for 1 kilogram, representing a 22% cost reduction. This primes us to capture a global market opportunity valued at over $2 billion. C-Plus has already generated some early customer interest, including the global packaging company Aurora. Our business model will seek to serve companies like Aurora by providing them with the bioplastic for them to then further develop into their own products. Our initial customer scoping has indicated that we can expect a price point of around $4 for 1 kilogram of our bioplastic product. This gives us an expected gross margin of 35%, where we're passing on our initial cost savings to our customer. And if all this wasn't enough, our product represents a true closed-loop solution, being both fully recyclable and 100% biodegradable.
At this stage, we've de-risked all existential threats to C-Plus through our rigorous technical testing. You're not just looking at a team with an idea, but a team with a proof of concept, that we can conduct C-Plus at a laboratory scale. Looking ahead, we plan to test the scalability of our technology in our pilot program. We have $75,000 worth of grant funding expected to hit by the end of the year, which will help facilitate the establishment of our own laboratory. This will also help us test our process and the economics of C-Plus at scaled production. And with an IP agreement already in place with our current lab, we're super excited to take this next big leap in our journey.
But this is really just the beginning here at Circle. Most textile recycling companies fail due to suffocating input and operational costs that don't scale. At Circle, we've specifically innovated around this cost problem. This is our moat. Whilst our initial IP protectable solution is focused on the production of bioplastics, our core fundamental process can be used to create a plethora of other valuable products. Think aerogels, fibres, films, rayon, you name it, our process can likely create it. And whilst we're confident we can seed into each of these product markets and become the renewable leaders, this isn't enough. We don't just want to be the best renewable alternative, we want to be the best product. We don't want to be the paper straw, we want to be the electric vehicle. Now, this is all a lot to take in, but if there's anything we want you to take from today's presentation, let it be the following 3 things. Number 1, we've innovated and solved the core problem at the heart of textile waste. Number 2, we've innovated specifically to address the cost problem such that it scales. And number 3, we're legally, commercially, and technically primed to take our next phase of growth and scale our core solution. Everything we build at Circle is built with sustainability in mind, which is why we address the following 6 key United Nations Sustainability Developmental Goals. What we're building at Circle gets us incredibly excited about the future, and we hope it gets you guys excited too. Thank you for listening, and we really look forward to answering your questions.
We will now begin the question and answer period. Only judges may ask questions.
I have a question about the biodegradability. Plastic is not biodegradable, and you're actually making plastic that at end of life, what happens to it? I know you said you can recycle it, but most plastics don't biodegrade, they just form microplastics. So how are you addressing that problem?
Yep, I'm happy to answer that one. So just to give a bit of context to our process, so the polyester that's in the cotton, that's separated and it undergoes its own kind of recycling process, but our bioplastic is purely cellulose. So the way that biodegrades is through commercial composting, which is readily available, and it's all about kind of setting those partnerships up with our companies that we will first seek to create this product with. But yeah, the core product that we're talking about with this bioplastic is purely cellulose, which means it's 100% biodegradable.
And just to add on to that, normal plastic takes lifetimes to biodegrade. Our product, we have research to back that we can 100% biodegrade our bioplastic within a third of a year. So that's where we set ourselves apart from traditional plastics.
Hi. I know when you sort of make these products, you're sort of solving a big problem in the environment. Have you calculated what the environmental cost of your process is, and is that actually better overall in terms of the recycling when you factor in the environmental cost of the processing that you're doing?
Do you want me to take this? Mm-hmm. Sure, I'm happy to answer that one. So essentially with our chemical process, and particularly with the ionic liquid, which is our core input, not only is it environmentally friendly in terms of the disposal because it's low toxicity, it doesn't require the high temperatures that are ordinarily needed for producing this bioplastic. And to add to that, it's almost completely capturable by the end, and so we can reuse that. So in terms of our chemical output, it's next to zero because the other liquid we use is water, and we can recover that too. And with our environmental input, that's something that we can toggle as we scale because that temperature is something that the ionic liquid can respond really well to at lower kind of ambient temperatures as well.
Hi guys. I love the concept. My question to you is, most academic research programs don't actually achieve commercial reality, and I understand that you do have an initial pilot kicking off, but longer term, what is it that you need to make Cycle really sort of take off and become material that's used in our everyday life?
Yeah, I'm happy to take that. Yeah, so of course that's a really good point, and kind of we've come in at the point now where a lot of this research is somewhat established, but the point at which we're innovating is bringing this research to commercial life, which is, as you mentioned, a difficult kind of hurdle to overcome. So initially, grant funding will help us sort of establish, can we do this at somewhat of a scale to where, the macro physics isn't hurting our core process. And then we'll look to raise money from either venture or private, public funds to help kind of become the core infrastructure at the heart of plastic recycling in Australia. So we want to be, cotton recycling in Australia. We really want to sit as the infrastructure layer to all of these companies with ESG initiatives, and they've got plastic products. They see us, we could create, a rayon or a film or a membrane, whatever it may be. They'll come to us and they'll identify that, as long as it meets the sort of technical specifications that we require, then we'll sort of sit as that core layer of infrastructure for plastic using companies as we move on.
Thank you. So you've chosen, just a question on your business model. So you've chosen an end-to-end manufacturing model as your business model. Can you talk through your logic there, why you're choosing that model as opposed to selling the IP and partnering with corporates that might have existing infrastructure to support?
Yeah, I can take that one as well. Yeah, so obviously there's sort of lots of ways to look at this. We even thought about vertically integrating to create our own plastic products, but we did sort of somewhat of a market scan to identify that for our core competency is really bringing it to market and selling it to these manufacturers. Whereas if we're engaging with partnerships, we may have to sacrifice, if it's a joint venture, for instance, we may have to sacrifice some of that IP. So for us, manufacturing, selling it to the manufacturers as sort of a wholesale agreement, that's what we identified sort of fits with our core competencies as a team. And so, yeah, I hope that answers your question.
And just to add to that with the infrastructure, unfortunately in Australia with textile recycling infrastructure, there's next to nothing. So with, partnering with an already recycling company, that wasn't even an option in Australia, unfortunately. So we kind of had to do it ourselves.
Hi guys. Firstly, come and find me afterwards. I'm Tommy from the Woolworths Group and love to have a more in-depth conversation. Secondly, what are the products that you are looking to develop, from a specific perspective around packaging and the like?
Yep, so I'm happy to answer that one. So particularly with the first kind of commercial discussions that we had with Aurora.
Question time has expired. Judges, please thank Monash University.
No, you recovered really well.